Okay, good morning, guys. Apologies for the troubles this morning. What I was saying is you really need to have finished these sections here, or be working through them at least. Today I'm focused on the normal distribution, and for the next week or so I'll be focused on the normal distribution. All of this stuff here is using tables, and if you don't have a graphics calculator, then you need to be able to use tables. There is one merit question, possibly excellence question, that will come up that will need some level of understanding of tables, but I'll make another video about that so that you're aware of how tables work. Right, you'll recall we played the memory game. That's another game that I sometimes play, but we didn't do it this week or this time. 11.8 was the mean. That was the average number of people, average number of items we could remember. And the standard deviation, the spread, as a measure of spread, is 2.4. More on standard deviation possibly when we get back to school. These are the questions we tried to answer, and these ones are straightforward, but I just want to show you, before I do that, I'll just do these questions, and then I'm going to show you an illustration of how what the normal distribution looks like. The probability that a randomly selected person can recall more than 13 items. And I was showing you on here, you have to go to menu and scroll across to the stats mode, execute, and then you look for distribution, normal distribution, and it's always NCD for this work. So click NCD. Now on my calculator I had another layer of complication, and it's the VAR button if you have that issue as well. But the lower amount would be 13. If I want to know how many people have more than, if I want to know the probability that someone can remember 13 or more, the lower amount is 13. Upper amount would be a big number like 100 or 1,000. The standard deviation is that symbol there, and that was 2.4 for memory. And the mean, that was 11.8. So all you have to do is pop in those numbers, hit execute, boom, your probability, didn't hit execute, the probability is 0.3. Now 0.3 should make sense to you, because remember, greater than the mean was 0.5, 50%. So then greater than 13 must therefore mean less than, the answer is less than 0.5. Now, at this point, let me just show you what the normal distribution looks like. Here it is. It's this shape here. It basically tells you that most people, in this instance, get around about 11. I haven't been able to put it on 10.8, but 11 will do. Most people can remember 11 of those memory pictures. There are some people that can remember 12, 13, 14, but there are less people that can remember 18, 19, and 20. There are less people that can remember 0, 1, 2, and 3, but the vast majority of us fall in this window. Now, it doesn't look quite right at the moment, does it? Because it goes way beyond 20. It's because my standard deviation's not right. Watch what happens, oops, wrong way, as I adjust standard deviation down to the correct size. It's gone off the screen. It was 2.8. Oh, sorry, 2.4. I don't think I'm going to be able to put it on a decimal. Well, I won't, but I can, but I won't. Let me just pause the video. I've just adjusted this axis so that you can see the top of the curve. Notice that there are a minuscule amount of people, and probably across the world, that would get 1 or 2 correct, and there is a few people across the world that would get 20 correct. And I've just adjusted the standard deviation down to 3, the mean at 11. You can, if you did another sample from a different cohort, they might have got 12. No, 12. And notice that the whole thing just shifts along a bit. Obviously, maybe not obviously, but the probability that someone gets between 0 and 20 is 100%. Obviously, this is a theoretical idea, so in other words, it goes beyond 20. See that? Which is impossible, but because it's not related to that particular test, that particular example, it's related to all examples that you can get a score or a measurement from. You can adjust the average and adjust the spread, and it will give you a different curve. So I just want to show you that if you adjust the mean to anything you like, the shape of the curve does not change. Okay, I'm adjusting the mean and the shape is just moving along the graph. However, if I adjust the standard deviation and make it larger, the shape, obviously, I keep saying obviously, but maybe it's not obvious, but the shape gets wider. Okay, as I make the standard deviation lower, the shape gets narrower, because standard deviation is a measure of spread. So that sort of gives you some inkling into what is happening behind the scenes when you're using a graphics calculator. This is called the bell shape or the normal distribution. Okay, keep going with my PowerPoint. Between 8 and 13, all you do here is make the lower 8 and the upper 13. Execute. Have a guess. I'm guessing about 40%, because it maybe a bit more, maybe 50%, because it sort of straddles the mean. The mean is 11.8, so the majority of people sort of fall between 8 and 13. Execute, execute. Oh, 63%. By the way, at the moment, actually forever, just ignore these z-scores. I'll talk about z-scores in another lesson, but all you're looking at is the probability, this line here. Let's look at the next question. It was, what is the probability that a randomly selected person recalls less than 8? So it's less than 50%, that's for sure. I'm guessing about, I'll say 25%. Graphics calculator, less than 8. So that means the upper is 8. How do I get that? Scroll up. Like me. Go up. Upper is 8. Lower you would think it's 0, wouldn't you? But let's just test it at 0. I'm just thinking to myself, when you look at this graph here, and I make this 11, what did I say? I'll make it 10.8. No, 11.8 rather. And when I make this, it's 2.4. No, it's going to work. I've made it between 0 and 8, so it's just this. In fact, the answer is going to be about 2%, because I can see on here, it's such a small area. It's actually, the area under the graph represents the probabilities. And so the area under the graph is always 1 or 100%. And so if you look at that area, the area below 8, 8's about there, isn't it, on that scale? Yeah, I'd say 10%. Let's go to the graphics calculator, see if I'm right. 5% or 6%, so somewhere around there. You can try and visually guess it, so you're happy with the answer the calculator gives you. Let me just, can you remember 5, 6, 6, 7? I just want to try something here. 5, 6, 6, 7, 5, 6, 6, 7. Get back. Exit. If I just put in a negative value, like negative 100, 5, 6, 6, 7, 5, 6, 6, 7. Yeah, 5, 6, 6, 7, yeah. Occasionally, yeah, anyway, that's another day. PowerPoint back here, that was the memory example, those were the questions. Here's some examples of when the normal distribution arises. Anything that you measure or you get a score from has a normal distribution. In fact, you know, you think about it, most people sort of average, and then there's some people that are better than average, and there's people that are worse than average, so that's why everything sort of falls in a bell shape. And I've just listed some examples: NCA, heights, weights, arm spans, etc., golf scores, 100 meter sprint times, CO2, rainfall, the Call of Duty, you guys play that maybe, number of points in a game of rugby. So everything is, not everything, sometimes they're left skew or right skew, but most of the time they are symmetrical, and that's an important part of the normal distribution. It has to be symmetrical. A little bit on, this is, no, forget that, another day. I should have given you enough information already to be able to do those pages in the workbook using your graphics calculator. You won't be able to do it if you haven't got a graphics calculator, so send me an email if you don't have a graphics calculator. That's it, folks. See you on Monday, and I'll cover off a little bit more about the standard normal distribution, which is essentially what tables is. Have a great weekend.